Okay, so if you can read that, it's saying that this charger is not going to work. Today we have a Nintendo Switch with no power and does not appear to be charging. So I'm going to plug this in real quick and just see what happens. So at 5 volts we are going straight to 0.17. Sometimes these things start out really low and the battery's dead, so I'm actually going to walk away and just leave this plugged in for a while. I won't plug it into the meter because that definitely kills them over time, but I will plug in the charger to an outlet or to a USB power supply and come back in a few minutes. Alright, let's see if anything is happening over here. And we're still going to 0.16, so you know what? 0.17, 0.16. Let's just open this up and see what it looks like on the inside. Quick peek at the charge port. It doesn't look great. Can't see anything. Oh, those are pretty worn on the edges there. Alright, let's open it up. Alright, so I've got this opened up. Actually went straight to the battery terminal here initially, and then as I went across, you can see it looks like something kind of sticky got in here, and if we continue, there's more on the charge port, and yeah, that screw's pretty rusted. So this has got a good chance of being related to liquid damage, although it doesn't look like it got too far. It looks like it was mainly near the port. So just out of curiosity, let's go ahead and unplug the battery real quick. Yes, I'm doing it with metal because guess what? I'm not touching anything that's not insulated. So somebody will leave a comment about that, I'm sure. Real quick too, let's take a look at the charging IC. Alright, let's find out if we did any damage to the charging circuit. And usually that will show up right over here. Alright, we got 356. Yeah, we got ground there, and I don't think that's correct. Yep, okay, so we've definitely got an issue going on here. And it is probably going to be this chip right here. 335, that's 498, 332, 412. That's supposed to be ground. Yes, it is. Okay, 437. Last but not least, always check this guy because you don't want to have a problem on that line. Alright, I'm going to pop the board out and we'll take a look at the other side. Okay, looks like we are definitely going to be doing a port. Probably a charging IC. I wanted to check, let's see, not too much more. You know, most of the moisture seems to have just gotten right into where the port is, so that's good for some things. And what I wanted to check here is this guy. It's hard to get ground with a bunch of corrosion all over the place. Okay, 356, that's good. And this filter is showing 700-ish on each side, so that's good news too. So I think that we'll only be looking at a charge port and almost definitely a charging IC. But what I like to do is go ahead and take the port out, and let's make sure that that short is still present near the charging IC, because occasionally you got something crossed up in here that's causing the problem. Kind of rare, but it can happen. So replacing the charge port did not solve the problem. We still have a short. I'll put a link here for a charge port replacement video in case you want to take a look at that. And we're going to check this also, so let's get this ready to go. Make sure that solves our problem and we're not replacing this for nothing. As these things are starting to I shouldn't say starting. They've never come down in price. Still like a good $7, I think. And they fail a lot. Right. And we are clear, looks like. So let's get this back on. Maybe a little more flux. Don't have to heat the heck out of this chip. Alright. Not quite lined up. Okay, see those run together? Alright, so this switch is back in business. As you can see, it is charging. I did want to point something out here, because a while ago I mentioned, because we were getting so many bad charging ICs on these things, I thought that there was a possibility that the USB-C cable that you use might have an impact on that. And someone pointed out that, USB-C is supposed to be pretty consistent across the board, so that really shouldn't be a problem. But today I noticed this. Now I've got a 100-watt power supply here connected to my USB-C cable, so this thing will put out more than twice what this is rated. You can actually charge a laptop, put this on a MacBook if you want, not a problem. However, if we take our video deal here, this basically simulates being on a dock, and we're going to plug the charger in here, and then we're going to plug this into the switch, and I don't know if you can see that, but it does not like this charger. It is not going to allow it to connect to the TV for whatever reasons. Let me just get back to that screen if we can. Okay, so if you can read that, it's saying that this charger is not going to work. So this aftermarket, which basically this is a charging cable from an Oculus Quest, and I just plug it into this power supply whenever I want to charge anything that's USB-C. But if you want to connect your switch to your dock, you're going to have to switch, no pun intended, as it recommends. At least I have one solution, and that is to go with the OEM charger. And once we plug this in, we can actually send the image from the device out to the out through the USB-C port. So it's all at your own risk, of course, but I have a feeling that using non-OEM USB-C cables is not the preferred method for charging this console.